Hello everyone, and welcome to WinWire webinar series. First of all, good morning, good afternoon, good evening to the folks joining from different part of the globe. My name is Noor Basha, Senior Marketing Manager at WinWire Technologies, and I'll be a moderator for today's webinar. So as most of you know, we are hosting series of webinar on topics of Azure, .NET, Visual Studio, AngularJS, every Wednesday at 9 p.m. specific time. So today's topic for the session is Azure IoT Hub, where we will learn how you can connect, monitor and control millions of IoT assets. So before we start, a few housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the end. And recording of this session will be shared to you in next 24 to 48 hours. So with that, let me take this opportunity to introduce you to today's presenter, my colleague Amit Dubey, who is the Director of Mobility and Cloud at WinWire Technologies. And he brings over 15 years of experience in the IT industry and is a Microsoft Azure certified specialist. With that, I would like to turn it over to Amit. Thank you.
Thank you, Noor. Welcome, everyone. Good morning, good evening to everybody who has joined. We're going to talk about Azure IoT Hub today. The agenda for the session is I'm going to give you a high-level introduction on Azure IoT Hub, what it is and what are the features that it provides us. And we're going to talk about the different protocols it supports for your devices. And we're going to see what are the advantages that you get out of using Azure IoT Hub. And then we're going to talk about how it actually works. So what are the different principles it follows for you to give the features. And then we're going to see a small demo. I'm going to show you how to interact with the Azure IoT Hub, like how to create one on the Azure portal and then how to interact with it. And at the end of it will be the question and answer session. You can ask any questions that you may have by typing in the chat window on your GoToWebinar, and then I'll answer them as many as I can within the time limit that we have. And if there are any questions that we are not able to answer now, then we will reach out to you on email. So with that, let's get started. So first of all, what is Azure IoT Hub? So it's a fully managed service that is provided by Microsoft that enables bidirectional communication with your devices. So say for example, if you're building an IoT application, the basic thing that you will need is you will need a service that your devices can interact with. So say for example, if they are sending any telemetric data, the data that they're generating. So you need to build a service that can accept those details from the devices, right? So basically, Azure IoT Hub is a core component of your IoT solution. So which is like a service provided by Microsoft. So it's a pre-built service that you can use. You can spin it up in a couple of minutes, and then you can register your devices onto the Azure IoT Hub, and then the devices can start communicating with your service. And then you can take the data and then process it behind the scenes. Once it reaches Azure IoT Hub, you can take it forward from there. So, and it provides like millions support to connect millions of IoT devices at one point simultaneously, and then send data. So it can handle all of that, and then you can scale it based on your needs. So what are the different things that it provides? So it provides a reliable device to cloud and cloud to device messaging. So as I said, it's bidirectional. So not only your devices can send messages to the IoT Hub, but cloud can also send, IoT Hub also can send messages to your device. So it's a two-way communication between the device and the cloud. So say for example, if you want to send a command to your device saying if you want to shut down a device which is not working properly, so you can just send a command. So if it can accept it and then respond to based on the command type and the parameters that you pass, you're good. So you can establish that bidirectional communication. And it provides security also. Every device has got its own unique identifier and a security key that it has to use when the device starts communicating with the Azure IoT Hub. So we're going to see more of that in the example, like how do you generate a key for a device, and then how it provides security. And then it also provides you monitoring. So if you go to the portal, then you can see how many devices have been registered on the IoT Hub, and what are the different messages that you're getting. There are other applications also, like something called Azure Device Explorer that you can use, which will give you a list of all the devices, and you can track each and every individual device to see what are the messages coming in from that device. So to that level, you can monitor the data on the Azure IoT Hub. And then lastly, it provides you a number of SDKs that you can use to build applications, program devices for that matter. So there are SDKs available for C#, C, and VB, Java, and all that stuff. So not only for .NET, but even other platforms, you have SDKs available that you can use to program your devices. So those SDKs actually make it very easy for you to program. So there are libraries that you can use to just initiate a device and then start communicating, right? So we'll see that as part of our demo also, like how I can create a device and how I can start sending messages using the SDK. Now, a lot of people might be thinking that earlier there was, in fact, it is still there. There is something called as Event Hub on the Azure subscription that you can find. So now you have Azure IoT Hub, then you have Event Hub, which was also very similar in nature. Like it could ingest a number of events, or millions of events at a time. So what is the difference between Azure IoT Hub and Event Hub? So we'll do a side-by-side comparison of IoT Hub and Event Hub. So if you see the communication patterns, so IoT Hub, as I told you, it provides bidirectional communication. So it's not just one way, like device to cloud. So it's like device to cloud and cloud to device. So that's one of the things of IoT Hub. But when you come to Event Hub, it provides you only one-way communication. So it can only accept messages from your devices. So you cannot send something back. So that is one communication pattern that is different. If you see the protocol support, then IoT Hub provides support for AMQP, AMQP over WebSockets, MQTT, and HTTP. So these are the different that are supported out of the box, but you can also write gateways. I mean, you can write an Azure IoT protocol gateway where you can write custom implementation of a protocol that you want to use and work with IoT Hub. So it provides you that as well. But if you come to Event Hub, then you have like only AMQP on WebSockets, and then HTTP. So it doesn't have MQTT or custom protocol implementation. Security, as I talked about, IoT Hub actually provides a device identifier and a security token for every device to communicate, and then you can revoke that at any point in time. So if you don't want a device to communicate, you can just remove that device, and then it will not be able to send any messages or receive any messages anymore. But when compared to Event Hubs, then it provides shared access policies with limited revocation support. So it doesn't have a device-to-device security access as with the IoT Hub. Operation monitoring, as I talked about, you can monitor like every individual device. You can get the number of devices that are connected, and then what are the devices that are sending messages, what are the messages that each device is sending. You can track it to that level. But when it comes to Event Hubs, you can get only aggregate metrics, like so many messages have been received on so and so time. So you can get aggregated metrics only on Event Hubs. Scaling, again, it's possible on IoT Hub, so you can connect to like millions of devices simultaneously. But with Event Hubs, you have only like maybe 5,000 AMQP connections as per the Azure Service Bus quotas. So it depends on that. Device SDKs, as I said, IoT Hub provides you SDKs for various other languages, not only just .NET, but even for Linux, and has support for other platforms also. But then with Event Hub, it has only support for .NET and C. The SDKs are not available. You can write code using REST API and stuff like that. But by default, it's there only for .NET and C. So looking at it, like if you want to really develop something for your IoT solution, where you have devices and you want to track each and every device, and you're concerned about security of each individual device, then you should go for IoT Hub. Is my recommendation. So depending on your needs, you can choose a component, but IoT Hub provides much more richer functionality compared to event hubs in terms of IoT applications. So let's see the protocol support. As I said, IoT by default supports AMQP and HTTP. Now, there are certain issues with HTTP because when you are doing HTTP communication with IoT Hub, you can hit throttling. I mean, throttling challenges, where you have like a number of devices sending HTTP messages. Though there is no restriction on AMQP, all the SDKs actually implement AMQP protocol. So if you're using HTTP, you might enter into throttling challenges. To overcome that, what you can do is, say for example, if your device can support MQTT, a protocol that a lot of devices support. If your device can do that, then what you can do is you can write a IoT protocol gateway. Now this is an application that resides on cloud, and then what happens is you can have communication between your device and the protocol gateway using MQTT, which the gateway then translates to AMQP and then communicates with the IoT Hub. So it acts as an intermediary between your devices and IoT Hub. So this protocol gateway is an application that you can write and host on cloud, and it converts your MQTT protocol to AMQP. So that is one way of achieving AMQP in devices that don't directly support AMQP protocol. Now, the other way of doing it is writing a field gateway. A field gateway is an application that resides on premises, which is there on your server, and your devices connect to the field gateway, and then the field gateway translates that to AMQP and communicates with the IoT Hub. So now field gateway is more useful for low power devices where you don't have lot of processing capability, or they can't reach out to the cloud for some reason. If you have that, then you can write the field gateway and implement your own custom protocol. Now MQTT protocol gateway code is available on GitHub, so you can just take a look at that and change it based on your needs, or if you want to implement some other protocol, then you can take a look at it as a reference. So with this, you can even write custom protocols where you have default support for AMQP and HTTP, and MQTT code is already available to write an IoT protocol gateway. So that is how you can implement custom protocols and support different protocols using Azure IoT Hub. Either use a protocol gateway or a field gateway, depending on your device limitations. So let's see some of the challenges that you mostly see when you're creating an IoT application that works with a number of devices. So most of these challenges are actually solved by IoT Hub. So we're going to just see what are these. So they're often embedded systems with no human operator, and then they are at remote locations where physical access is very expensive. So say for example, if you're having devices, so they are basically like embedded systems, and then are available at various different locations where you have deployed them. But you cannot have human support at each and every region, which is practically impossible. You cannot have somebody monitoring your device individually at every different location where you have deployed it. So with IoT Hub, you can just create a communication channel for those devices so that you can monitor it at one single location. All the devices that are spread across, you can monitor it with one solution. So again, if you're writing a solution backend, they may be reachable only through that, and they have limited power and processing resources. So if you have devices that have very limited processing capabilities, so you cannot process the events being generated at the device itself, right? So in order to do that, you take the message to the IoT Hub and then process it over there. So that is the advantage that you get out of IoT Hub, and then you can scale it as per your needs. So if you are getting a number of events at any given point of time, you can scale it up and scale it down and work based on that. And again, you will see that a lot of devices will have slow or no network connection at some times. So how this is solved is like whenever you send a message to IoT Hub saying, okay, send this message to a particular device, but that device is not having an internet connection at that point in time, what IoT Hub does is it stores the message for you in a queue, and then there is a time to live for that message, so you can define that time to live duration. So it keeps that message for that time, and then whenever the device has an internet connection, when it connects back to the IoT Hub sends that message. So that problem is also solved. So if you have no network connection for some time, then your message is still there. It will reach to your device when it becomes available. And then many of the devices are restricted with proprietary, custom, industry-specific protocols. So you can write your own implementation of those protocols, as I just explained in the previous slide, to support that. And then it can be created for large number of hardware and software platforms by the SDKs that are provided by Microsoft. So those are some of the challenges that are actually solved by using Azure IoT Hub. Now, there are a lot of advantages that you get when you use IoT Hub. So as we talked about this, most of them like per device authentication and secure connectivity. So in order for your devices to communicate with the Azure IoT Hub, you have to first register them with a unique identifier for the device, and then provide a security key, or the IoT Hub will give you a security key. And then the device has to use it as a combination of username and password. So your device ID and the security key that you get will act as a username and password for your device that you can use to send messages or receive messages from the IoT Hub. So security is taken care of. And then monitoring of connectivity, you can either use the portal to see high-level information about the number of devices and the number of messages that you have coming in, or you can use other applications like Azure IoT Hub Device Explorer, which is available on GitHub. You can run that application and connect to your IoT Hub and see all the devices that are registered and monitor each and every individual device. And then you have an extensive set of device libraries. So if you're familiar with the programming language like C, C++, C#, or VB.NET or Java, then you can just use the SDK to easily program your devices. So you don't have a huge learning curve over here. So you can work with the languages that you already know. Protocols and extensibility we talked about. You can write protocol, IoT protocol gateway or a field gateway, depending on your device's limitations, and then work with the IoT Hub by writing a custom protocol implementation. And by default, as you know, it already supports MQP, HTTP, and MQTT. Scaling is also possible. Like when I show you in the demo, like when you create an Azure IoT Hub, you can send a certain number of messages depending on the tier that you're choosing. Now you can scale it up. You can add more units to it, and then keep increasing the number of messages that you can accept through an IoT Hub. So scaling is easily possible when you're working with IoT Hubs. So let's see how IoT Hub works. So it works on service-assisted communication pattern. So this pattern has some principles that it follows, and those principles are like basically security is the topmost priority. So it takes precedence on everything, as I talked about. Like every device must have a security key to start communicating with it, and even to register devices, you have another key, which is your SAS token that you get from your Azure IoT Hub that you have to use when you are registering the devices. And then the devices will only follow the established routes, so they are only communicating with the IoT Hub and not communicating with anything else. The protocol layer is secured at the application, and the communication between the device and the gateway is can be HTTPS, so that is also more secure. System level authentication and authorization are also available on a per device identity. Bidirectional communication is again possible between the device and the cloud. And finally, the payload data is all secure. So you are sending some messages, you're adding devices, they are having some keys. All that data is stored by the IoT Hub, but you are not having direct access to it. So all the data you can access is only through the services that are provided by the IoT Hub, and that data is completely secure. So those are the basic principles on which the Azure IoT Hub works. Now let's see a quick demo. I'll show you how you can create an Azure IoT Hub on the Azure portal, and then we'll write a simple application that you can use to register devices on the IoT Hub, and then start sending messages, and then we'll see how to capture the messages. So that is not a part of this demo, but I will take those messages from the IoT Hub and put it in a SQL Server database. So let's see that. So if you see here, I've logged into my Azure subscription. I'm going to the new portal now. So this is the new portal that most of you must have seen. So if I want to create an IoT Hub, I click on New, and then I type, say, IoT. So you get an option to select IoT Hub, and then you get IoT Hub over here. So if you select it and say create, that will create an IoT Hub for you. So you have to give it a name. So I will say demo. So if it is available, then you get a green check mark, which means that it is available. Otherwise, it will give you an error message saying you have to choose a different name. Now, pricing tier. So there are 3 tiers available right now. S1 is basically like you can send, if you choose S1, you can send 400,000 messages per unit per day. So by default, when you create an IoT Hub, it creates 1 unit for you, and you can scale up to 200 units. So that is how it works. And then if you choose S2, then you can send up to 6 million messages per unit per day, and then again you can scale up to 200 units. By default, you get 1 unit. So you can choose the number of units over here, how many you want, and the price that you see is per unit. So if you want to try out IoT Hub without any money being spent, you can always choose the free version. Free version supports like 8,000 messages per unit per day, but you can have only 1 unit on this. And then you can have only 1 free IoT Hub on a subscription. So I've already created one, so I don't have an option to create another one. So we can just say S1, and then you say create, and IoT Hub will be created for you. So I've already created one, so I will try and use that one for this demo. Close this. Now let's go to the application. Now, in order to work with devices, so there are 2 steps, as I said. First thing is you have to register a device, and second thing is you have to send messages, right? So in order to do that, you need two SDKs. So the 2 SDKs are basically, one is your devices SDK. The devices SDK is used to register devices on the IoT Hub, and the device client. So device client is basically when you're programming the devices. So if you want your devices to connect to the IoT Hub and send messages, you use the device client SDK. And device SDK will be used by the application that registers the devices. Now in my example, so I have a device manager. If I go to say manage NuGet packages on this, I have added both the packages into this, because in one application only I'm adding the devices to the IoT Hub and I'm sending the messages also. So if you see the devices client and the devices, so these are the 2 packages that you will need in order to work with the IoT Hub, right? So I've already added those NuGet packages. Now, if you want to see the code, first what we do is we create a registry manager. From the IoT Hub connection string. So when you create an IoT Hub, you get a connection string. So I have it here. So you have to give the host name, which is your IoT Hub name, and the shared access key name, IoT Hub owner, and the key. So all this you can get from the portal. You can directly get the connection string for the IoT Hub that you created from the portal and replace it over here. And then I have a SQL connection string to my database that I have, where I'll be storing all the devices and the messages that I get from the devices into this database. So we create a registry manager. Registry manager can be used to register devices on the IoT Hub. So we have created an instance of it. So here what I do is, if you see this, just one line of code that actually adds your device to the IoT Hub. So I said just registry manager dot add device async, and I create a new device. I provide a device ID. Now this device ID is nothing but a string that is a unique identifier for your device. So it could be anything. It could be any value. You can say my device, or you can have a grid or something. All right. But the only thing is it has to be unique on the IoT Hub. So if you give a duplicate value for this, so say for example, if I already registered a device with a name, if I try to register it again, I get a exception called device already exists exception, which I'm catching here. I'm showing the message saying the device already exists to the end user. So that is how you add a device. And then sending messages. Now sending messages is like, okay, so I have the code here. So you use the device client here. So device client SDK that you have already added. So you create a device client by giving the name of the IoT Hub, and then you register the authentication you provide by giving the device ID and the device key, right? So once you register a device, right? So device ID you provided, device key you will get it like after registration. I'll show you here. So here, right? So when you say add device, it returns a device to you. Now this device has a property called device.authentication.symmetric key.primary key. So this is the key that Azure has provided you for this device that you just registered. So I'm using this device ID and the key that I got to send a message to IoT Hub using the device client. Okay, so that is the whole thing. Let me just quickly run this for you. So these console applications I have actually to capture the message from the IoT Hub and then store it on SQL Server. So okay, so let's see. In the devices drop down, I have two devices which I already have registered. So let me add a new device. I will say webinar device. Say okay. Okay, so it says device registered successfully. So let me just quickly see. So I'm storing it in SQL as I said. So here you can see I have the webinar device and it has already given me a key that I have captured. So if I go back to the portal, right, so let me just select the IoT Hub that I had. So here you can see it's still saying 2 devices, but after some time you'll see that this count will increase to 3. Now let me send a message also. So I choose whichever device, say for example if I want to send a message from this device. So the device that we just added, I'm just saying hello world and I say send. So I sent it to the Azure IoT Hub, and if I say select start from device message, you see that I have already captured hello world in this, right? Let's go back to the Azure IoT Hub and let me refresh this to see if I see any change in the number of devices. Yeah, so now you see the number of devices that I have is 3, and I've already sent 2 messages out of the 400,000 capacity that I have based on the 1 unit configuration. So 1 unit and this is an S1. So that is how easy to actually register devices and send messages using your device client. So if you have any questions, please feel free to ask. Then I can start answering them one by one.
Sure. Thanks, Amit. Thanks for the quick demo and a quick session. Yes, I do have few questions coming in here. We got a couple of more minutes. So the first question is, can I specify my own security key when registering a device?
Yes, you can do that. I mean, if you see in the example that I did not provide any security key, I just gave the device ID when I was registering a device. So in that case, Azure gives you a key that you can use. But if you want, you can provide your own key as well, and then that key will be used to program the device.
Great, thanks. So the next question is, how can I stop a device from communicating with IoT Hub?
Yeah, so you created the registry manager and then you said add device to IoT Hub, right? So similarly, what you can do is you can have a method to remove device also. So you provide the device ID and then you can remove the device, which means that device registration is gone from the IoT Hub. So when the device tries to communicate, it will fail to the IoT Hub because that device no longer exists as part of the IoT Hub.
Thanks. So the last question for the day is like, how can I send messages to the device?
Yeah, so in the example you have seen that we have sent a message like from device to cloud. So devices were sending messages to the cloud, but you also can use the SDK, the devices SDK, to send messages to a particular device. So you can provide the device ID that you have for a registered device, and then you can send a message by using the devices SDK.
Okay, thanks, Amit. We know we are almost there. So folks, if you have any further questions, I request you to write it to us at marketing@winwire.com, and we will take them offline. So thanks everyone for taking time to join this webinar, and I hope you found it informative. As you see on the screen, our next webinar is on Visual Studio Online, where you will see how you can leverage Visual Studio to build next-gen applications. So we look forward you to joining to this next webinar. Thanks and have a good day. Thanks, Amit, for the wonderful session.
Thank you, everybody. Thanks for joining. Look forward to seeing you next week. Thank you, Noor.
Thank you.